In this video, we're going to learn about linear functions. Now, linear functions are called that because when you graph them, you're going to get a straight line. Now, there's a very important defining characteristic of linear functions, and we're going to see that by looking at this table here. So the idea is, if you look at your table, now I made it so that all the x values are increasing by 1 each time. And you see what happens to the y each time here. I go down by 2. So what that means is I'm changing my y value at the same rate every point to point to point. Now, in other words, that's the slope. The slope is always going to be the same here. So that means this is a linear function. So again, the defining characteristic of a linear function is that your slope, or your rate of change, is always going to be the same from one point to the next. It's never going to vary. Now, if you look at this second table here, on this second table, again, my x's are always increasing by 1, but my y, it increased by 4, and then by 12, and then continues by different numbers there. So my slopes are all different there. This is not a linear function. So again, the idea of linear function is you're going to keep adding the same amount or subtracting the same amount every single step. The second one here, it's not a linear function, it's not part of this video here, but I wanted to point out that each time I'm actually multiplying by 3, and that follows for all of them. And when instead of adding by a number or subtracting, if you keep multiplying or dividing by a number, that's going to be called an exponential function. We are going to have a whole separate video on that later, but I just thought I'd point it out since we're looking at tables here. Okay, now I actually skipped over this, but I wanted to show you the property first, is that, because of that same slope, you can actually write out any linear function as mx plus b. So anytime you have a formula, if you can write it as mx plus b, that's going to be a linear function. Now, it turns out that linear functions are used all the time in mathematics and in science and engineering. One of the reasons why is that it's generally quite easy to solve equations when they're linear. And it turns out that things that are not linear sometimes are so difficult that we literally cannot solve them, at least not perfectly. And so what we end up doing is we end up using linear equations as approximate answers and solve lots more problems that way. So it turns out that linear is kind of where it's all at. Most real-world applications, they're going to use some sort of a linear function to try to approximate what's going on because they're much easier to work with. Now, for the example I gave in this video here, this is one where it actually is a perfectly linear function. It's not approximation. So let's take a look at it. It says you decide to rent a van to help you move. The company charges $19.99 for a one-day rental plus 59 cents per mile you drive the van. Write a formula that shows the total cost if you drive X miles. So X is going to be the number of miles. They give us that in the problem. I'm going to call C the total cost. And so we can write our formula here. C is the fixed value of 19.99 plus the variable cost, which is 0.59 times the number of miles we have, because it's 59 cents per mile. And this would be our formula. Or if you wanted to write it as a function, C of x, and I'm also going to write it in the standard mx plus b format, 0.59x plus 19.99. So there would be a way to give a function that describes how much the total cost is going to be when you drive X miles using this rented van.